The fastest spaceship we've ever launched, if you aimed it for the closest exoplanet, would be headed toward Proxima, a planet located just 4 light-years away. Proxima is relatively close, and we may one day pick up signals from an extraterrestrial civilization on this nearby planet, which might be similar to Earth. Astronomers have made an unexpected discovery on the dark side of Proxima Centauri B, a side that has never seen the light of its star. For years, we believed this side to be nothing more than a cold, lifeless shadow. However, recent observations are revealing something different, a faint yet unmistakably out-of-place signal coming from the darkness. Emissions from Proxima Centauri B's dark side. As scientists peer into the darkness of Proxima Centauri B, something unexpected is becoming clear. Emissions are coming from the dark side, faint but distinct signals that could be unlike anything we've seen before. These emissions might take many forms, including artificial light, heat radiation, or other types of electromagnetic radiation, such as infrared. What makes these signals different from natural starlight is their unique signature, suggesting they are man-made or a product of a sophisticated system. Unlike the constant glow of a distant star, these emissions can be detected using powerful telescopes like the James Webb Space Telescope, JWST, which is specifically designed to spot infrared radiation, the type of faint energy that might be escaping from Proxima Centauri B's dark side. What if these emissions aren't just from lights but hint at something even more intriguing on Proxima B? Could they tell us a story we've yet to uncover? One that points to a hidden civilization or a mystery much deeper than we could have imagined. The faint emissions could be more than just signs of energy use. They might provide key insights into the planet's inhabitants, if any. If these emissions are artificial, they could indicate a technologically advanced civilization. The specific patterns of light and heat might reveal the type of technology in use, the scale of energy production, and even hint at the social structures of the planet. Imagine how Earth's city lights tell the story of our political boundaries and social conditions. Brightly lit cities reflect economic power and political priorities, while dimly lit areas might indicate poverty or lack of infrastructure. Similarly, emissions from Proxima Centauri B could reveal an entire civilization's values and priorities through their energy use. Could the dark side of Proxima B reveal more than just city lights? What if it shows us an alien society in action, how they govern, their technological advancements, or even their struggles? These faint signals may offer us our first glimpse into an entirely different way of life, light years away. Tidal locking, a phenomenon where one side of a planet always faces its star, while the other remains in complete darkness, profoundly impacts emissions on Proxima Centauri B. Since Proxima B is tidally locked, its dark side remains in perpetual shadow, making it extremely cold and inhospitable without a source of heat or light. Artificial lights would likely be essential for any life that exists there, providing both warmth and illumination, making the dark side habitable. Without these artificial energy sources, the dark side would be too cold and dark to support life as we know it. The unchanging nature of tidal locking creates a consistent pattern on the dark side, which means the emissions detected could be steady and predictable. Astronomers might even be able to detect how much energy is being used to sustain life on that side of the planet. Future telescopes, like the James Webb Space Telescope, JWST, and the proposed LUVOIR, are designed to detect incredibly faint emission signals that could reveal the existence of extraterrestrial life. These advanced instruments are equipped with technologies that allow them to capture narrow bands of light, particularly in the infrared spectrum, which is crucial for identifying artificial emissions. Unlike natural starlight, which floods our observations of distant stars, these faint signals could be distinctly different, making it possible for astronomers to pick up on something far more exciting: artificial light. What sets JWST apart is its ability to focus on specific wavelengths of light emitted by artificial sources. The infrared sensitivity of these telescopes means they can detect the heat radiating from a planet, even from light years away. This is crucial because artificial lights on Proxima Centauri B's dark side could emit detectable heat, allowing scientists to analyze these wavelengths to distinguish between natural starlight and artificial light. The potential to detect these faint emissions could mark a groundbreaking shift in our search for life beyond Earth. We are on the verge of discovering not only new planets but also potentially signs of intelligent civilizations. The technology behind JWST and LUVOIR could help us spot a civilization on a distant world just by detecting a pattern of light unlike anything we've ever seen before. But there's more to it. What kind of technology would be required to create these artificial lights on Proxima B? The implications of this discovery go far beyond just detecting emissions. They could reveal the technology that allows life to thrive in an otherwise inhospitable environment. To make Proxima Centauri B's dark side habitable, extraterrestrial civilizations would need advanced technologies to generate light and heat. One possibility is the use of photovoltaic panels, solar cells, that convert sunlight into electricity. Although the dark side of the planet doesn't receive direct sunlight, these panels could be placed on the permanently sunlit side, harnessing solar energy and storing it for use on the dark side. Other advanced energy sources might include nuclear fusion reactors, which could generate vast amounts of power without relying on solar energy, or even artificial photosynthesis, a technology that mimics the process plants use to convert light into energy. These artificial lights would serve two key functions: providing light and warming the dark side, making it livable. Just as Earth relies on electricity for everything from streetlights to homes, Proxima Centauri B's inhabitants could rely on sophisticated lighting systems to illuminate their world and maintain a habitable temperature in the constant shadow. Could these artificial lights be an indicator of something much larger, perhaps an advanced technological society? The lights themselves may not just be a survival mechanism. They could point to a civilization with remarkable energy management and engineering capabilities, able to control their environment on a scale we haven't yet imagined. The very existence of these lights could suggest that Proxima Centauri B's inhabitants have mastered technologies that seem like science fiction to us. While emissions from the dark side of Proxima Centauri B have been detected, understanding or analyzing them presents significant challenges. First, the vast distance between Proxima Centauri B and Earth makes it extremely difficult to isolate the faint signals coming from such a distant world. Even with the emissions we've detected, their faintness makes it hard to distinguish them from background noise. Proxima Centauri's solar flares and cosmic radiation further complicate the task, potentially interfering with the clarity of the signals we're trying to study. However, advancements in telescope technology are pushing the boundaries of what's possible. Instruments like JWST and future telescopes like LUVOIR are designed to focus on specific wavelengths of light, including the infrared emissions that could originate from Proxima B. These instruments are incredibly sensitive, and with their help, astronomers can isolate these emissions with greater accuracy, despite the distance and interference from cosmic phenomena. Could Proxima Centauri B's natural emissions confuse scientists into thinking the planet is just another barren rock? Despite breakthroughs in detecting emissions, it's still possible that what we've identified is just the beginning. With the right advancements in technology, the real story may yet remain hidden beneath a layer of cosmic noise. While emissions from Proxima Centauri B's dark side have been detected, some of these signals could be natural phenomena, not artificial lights. Earth itself provides examples of such emissions, like shimmering auroras caused by interactions between solar wind and our magnetic field. On Proxima Centauri B, volcanic activity or atmospheric phenomena like auroras could produce similar glowing emissions. In fact, the planet's unique position, constantly facing its star on one side, could lead to dramatic volcanic or geothermal activity, releasing heat and energy into the atmosphere. This complexity could make it difficult to distinguish between artificial light and natural emissions. Just like auroras on Earth can sometimes appear bright and otherworldly, volcanic lighting or intense storm activity on Proxima Centauri B might give off emissions that could be mistaken for a city's glow. The faintness and irregularity of these emissions might cloud our understanding of what's really happening on the dark side. Could Proxima Centauri B be hiding something under its surface? What if these emissions aren't from a city, but from a planet teeming with volcanic activity? The mystery beneath the planet's surface might be far more complex than we ever imagined, suggesting that the dark side of Proxima Centauri B could hold more than just a few lights. It could harbor a dynamic, ever-changing environment. Proxima Centauri B's atmosphere could significantly influence the emissions detected from its dark side. If the planet has an atmosphere, it could act as a filter, altering or absorbing certain wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, some of that light might be absorbed or scattered by the atmosphere, making detection much more difficult. The composition of Proxima Centauri B's atmosphere, whether it's rich in gases like carbon dioxide, nitrogen, or even exotic compounds, could change how the light behaves as it travels through it. For instance, certain gases can absorb specific wavelengths of light, which would alter the light's spectral signature by the time it reaches our instruments. This means that even though we might be detecting something from the dark side, we might not fully understand its true nature without considering how the atmosphere has affected the emissions. What if Proxima Centauri B's atmosphere holds the key to understanding how emissions from its dark side could reveal the planet's history? The way the atmosphere filters these emissions could provide insights into the planet's past, how it developed, what kind of environmental changes it's undergone, and whether it's capable of supporting life. By leveraging the power of next-generation telescopes like JWST and LUVOIR, we're on the brink of unlocking profound discoveries. These instruments could reveal faint emissions from Proxima Centauri B's dark side, potentially unveiling signs of life or technology on a distant world. With these breakthroughs, we'll not only answer questions about the planet's habitability, but also open the door to exploring what could be an entirely new chapter in our search for extraterrestrial life. The future of space exploration is exciting, and with each advancement, we get closer to discovering whether we are truly alone in the universe. These discoveries will change everything we know about the cosmos, and we are standing on the edge of something monumental. If you enjoyed this journey into the unknown, don't forget to like and subscribe for more updates as we continue to explore the mysteries of the universe. As we look toward the future of space exploration, the potential discoveries surrounding Proxima Centauri B continue to captivate our imagination. The next generation of telescopes, such as the James Webb Space Telescope, JWST, and the upcoming LUVOIR, could revolutionize our ability to detect distant signals that might indicate the presence of intelligent life. By studying Proxima Centauri B's emissions, scientists may be able to gain unprecedented insights into the planet's atmosphere, surface conditions, and, potentially, its habitability. Astronomers are particularly interested in how these emissions could reveal information about the planet's geological activity. If Proxima Centauri B has an active interior, it could be experiencing processes like volcanic eruptions or tectonic shifts that release significant amounts of energy into its atmosphere. These natural phenomena could create emission patterns that might initially appear to be artificial. Therefore, distinguishing between natural and artificial signals remains one of the greatest challenges in exoplanet research. The presence of volcanic activity on Proxima Centauri B could provide clues about the planet's internal structure. For example, active volcanoes would indicate that the planet's mantle is still warm and generating heat, which might be essential for maintaining a stable environment on the dark side. Volcanic eruptions could also contribute to the presence of gases like sulfur dioxide, which would alter the planet's atmosphere and potentially affect the way light and heat are absorbed or scattered. This could make detecting artificial light sources more difficult, as the atmospheric interference would obscure the faint emissions. Another intriguing possibility is the role that Proxima Centauri B's magnetic field might play in shaping its emissions. Earth's magnetic field, for instance, helps protect our planet from harmful solar radiation and plays a crucial role in phenomena like the auroras. Proxima Centauri B may have a similar magnetic field that interacts with its star's solar wind, which could influence the way energy is distributed on the planet's surface. This interaction could create patterns of energy emissions that might be mistaken for technological activity. Understanding the magnetic environment of Proxima Centauri B would, therefore, be crucial in interpreting the signals we detect from its dark side. If we do eventually confirm that Proxima Centauri B harbors life, whether microbial or intelligent, one of the most profound implications would be the knowledge that we are not alone in the universe. The discovery of a technological civilization on a distant planet would raise a host of questions about the development of life in different environments. How might an alien society evolve in an environment where one side of the planet is in perpetual darkness? How would such a society adapt to the extreme conditions of their world, and what kinds of technologies would they develop to survive and thrive in such a hostile environment? In addition to the search for life, the study of Proxima Centauri B could also offer valuable lessons about the potential habitability of exoplanets in general. Scientists are particularly interested in the concept of the habitable zone, the region around a star where conditions might be just right for liquid water to exist. While Proxima Centauri b is in the habitable zone of its star, its tidal locking and extreme conditions may challenge our traditional understanding of what constitutes a habitable environment. The discovery of life on such a planet would push the boundaries of our knowledge and force us to reconsider the factors that make a planet suitable for life. Proxima Centauri b is just one of many exoplanets that scientists are studying, and each new discovery brings us closer to answering the age-old question of whether we are alone in the universe. As technology continues to advance, we may one day find clear evidence of life beyond Earth, perhaps in forms we have yet to imagine. The mysteries of Proxima Centauri b are only the beginning, and the future of space exploration promises to be filled with exciting breakthroughs that could forever change our understanding of life, the universe, and our place within it. In the coming decades, humanity's exploration of space will undoubtedly lead to more missions aimed at discovering exoplanets that are even further from our reach. These missions will rely on the collaboration of scientists, engineers, and space agencies from around the world to develop the tools needed to analyze distant worlds. The technological advancements in telescopes and space observation platforms will continue to improve, bringing us closer to identifying signs of life on distant planets. It is an exciting time for astronomers and space enthusiasts alike, as the search for extraterrestrial life advances to new frontiers. The discovery of a distant civilization could be the key to unlocking some of the universe's most profound mysteries.